In this video, we're going to learn about single replacement reactions. Not all single replacement reactions occur, but we've learned previously that the basic general format for single replacement is when you have a single element which replaces an element within a compound. So in this first example, A replaced B to form AC and then left B to be alone. Or A could replace C, leaving C alone, where A is in this case, a nonmetal combining with B, the metal. In the first example, that's a metal combining with the nonmetal. In order to determine whether or not a reaction will occur for single replacement, we use what's called the activity series, which can be found in your reference packet. The single element must be more reactive than the element it will replace, and the more reactive elements are at the top, where the least reactive elements are at the bottom. You have two separate activity series, one of the halogens, where fluorine is the most reactive and iodine is the least reactive. And then you have one with metals, where lithium is the most reactive, all the way down to gold being the least reactive. You will note that hydrogen is present in this, even though it's not a metal, but it is part of the reactivity series. All right, so let's look at some examples. For the first one, we have iron reacting with silver nitrate. So we need to find iron on our reactivity series, and we find iron is right here. And then we find silver, which is right here. Now, because iron is higher than silver, this reaction will work. So that means that iron will replace silver. So iron will combine with nitrate, leaving silver by itself. Now, for transition metals such as iron, we're going to use a +2 charge unless specified otherwise. So we're going to say iron is +2. We find nitrate on our polyatomic ion list, and it's a -1. And so those have to add up to 0, just as they did before, so we have to multiply by 2. So we have iron with 2 nitrates, FeNO3, 2. And then, of course, we have to balance. Since we have 2 nitrates, we'd have to have a 2 here in front of the silver nitrate, and then we have to have a 2 here for our silver. All right, for number 2, we have magnesium reacting with lithium chloride. So again, we need to look at our activity series and decide, will the reaction occur? So we find magnesium and lithium. Here is lithium, and here is magnesium. In this instance, magnesium is below lithium, which means magnesium is not reactive enough to replace it. So there would be no reaction. And that would be what we would write, just no reaction, because nothing would happen. All right, so for number 3, we have that chlorine is reacting with magnesium bromide. Again, we need to look at our activity series. In this example, we're going to look at our halogens, since chlorine is a halogen. So we see that chlorine is above bromine. Since chlorine is above bromine, this reaction will occur. And that means that chlorine will replace bromine. So chlorine will combine with magnesium and then leave bromine by itself. Now we have to use our charges to write our formulas correctly. So the charge for magnesium, since it's in group 2, is +2. The charge for chlorine, since it's in group 7, is -1. Those do not add to 0, so we'd have to multiply the chlorine by 2. So we have MgCl2. Again, the 2 here is because we had to multiply by 2, not because of the 2 on the other side. Now, when we have a single element here by itself, such as bromine, we have to ask ourselves the question, is it diatomic? Remember, your only diatomic elements are nonmetals, so you don't really have to ask yourself the question as in number 1, because silver was a metal. But when it's a nonmetal, you do. And so bromine is one of our 7 diatomic elements. and so we'd have to have a subscript 2. And then, of course, you have to balance. So you have 2 chlorines, 1 magnesium, 1 magnesium, 2 bromines, 2 bromines. And so now this reaction is balanced. All right, I want you to pause the video and I want you to try these 3 on your own. And then when you're finished, return and hit play, and then we'll go over them. All right, so for number 4, we want to find lead and iron on our chart. So we find iron is here and lead is here. And again, the single element lead has to be higher than the one in the compound. Since lead is not higher, this reaction will not occur. So we would write no reaction. For number 5, again, we have to look at our chart. We find lithium is up here, and then copper is way down here. Since lithium is indeed higher than the copper, this reaction will occur. So lithium is going to replace copper. So lithium would combine with sulfate, and we would leave copper by itself. All right, again, we have to use our charges to write our formula correctly. Since lithium's in group 1, it is +1. If we find sulfate on our polyatomic ion list, we find that it is -2. Since those do not add to 0, we would have to multiply our lithium times 2, which means we would have 2 as our subscript for lithium. Now we have a single element copper. It is a metal, so it would not be diatomic because our diatomic elements are only nonmetals. All right, then we need to balance. So we have 1 lithium on the left, but 2 on the right, so we'd have to multiply by 2. And then we have 1 copper on the left, 1 copper on the right, 1 SO4, and then 1 SO4. And so this would be balanced. All right, number 6, we have to use our activity series for our halogens since fluorine is a halogen. And so we would look up fluorine and then bromine, and we see that fluorine is indeed higher than bromine, and so this reaction will work. So fluorine is going to replace bromine, which means it will combine with potassium and then leave bromine on its own. Again, we have to use our charges to write the formula correctly. Since potassium is in group 1, it's +1. Fluorine's in group 7, so it's a -1. In this instance, they add up to 0, so we would need no subscripts. Now we have bromine by itself, right? Since it's a nonmetal, we have to ask ourselves the question, is it one of our 7 diatomic elements? And the answer to that is yes, indeed it is. And so we need a subscript 2. And then we would have to balance. So we have 2 fluorines on the left, but only 1 on the right. So we'd have to multiply this by 2. Now that gives us 2 potassiums. So then we would need to multiply the potassium bromide also by 2. But that 2 also goes to the bromine, but that's okay because we already have 2 on the right-hand side. And now this reaction is balanced. All right. So at this point, you need to go take the quiz using the link in your assignment to check your understanding for this video.